Welcome back. This is Zahin Azir and we are doing Advent of Cyber 2024 on TryHackMe.com. Um, so we're gonna start from task 18. So yesterday we completed our task 17, and today I'm gonna complete maybe 3 or 4 more tasks so we can complete all of this by 31st. Awesome. Okay. Task 18, it is web timing attacks. Day 12, if I can't steal their money, I will steal their joy. Story. So there is already a walkthrough by Tiberius. He's a really good mentor on X and also available on YouTube. He runs his own Twitch channel as well. Check it out, guys. We're gonna create our own walkthrough. Ware Valley's bank had a huge turnover this year and expected a massive profit before the holiday season. They are eager to disclose this news to the townspeople during the SOG mass celebrations. However, to their surprise, things went the other way around. After completing the annual calculations, the accountant was shocked to see a considerable loss. Okay, they observed discrepancies in the account balances. Okay, this is strange. The bank called MaxKitty to help investigate these users' fraudulent transactions. Upon analyzing the bank's website's transactional logs, MaxKitty found some interesting transactions. Few users, including the mayor's team, initiated multiple transactions from Ware Valley's reserve account at once. Okay, mayor's team, huh? Surprisingly, all these transactions succeeded despite exceeding the user's current balance. Oh wow. The glitch was already aware of the critical vulnerability, allowing these fraudulent transactions. The mere malware and his alliances exploited. Okay, so this is the Ware Valley Bank, and as we can see from the animation that the money is evaporating out of the bank. Learning objectives: understand the concept of race condition vulnerabilities, identifying the gaps introduced by HTTP 2, exploit race conditions in a controlled environment, learn how to fix the race. Connecting to the machine. So we already have connected to the attack box, as you can see here. Let me open a terminal as well. All right. And then I already started the machine as well. As you can see, this is the machine already up and running, and it should be, the website should be accessible, right? Okay. Let me open up the Firefox now, and I will copy paste the link here. And here we go. We have login page available here. Maybe we will have credentials as well. Do we have credentials? We don't have credentials, I think. So, okay, click on the green start machine button shown below. This text to start the virtual machine. We are already done so. I already started the attack box as well. We access the website as well. We are good to go. Web timing and race conditions. Okay. Conventional web applications are relatively easy to understand, identify, and exploit. If there is an issue in the code of the web application, we can force the web application to perform an unintended action by sending specific inputs. These are easy to understand because there is usually a direct relationship between the input and output. We get bad output when we send bad data, indicating a vulnerability. But what if we can find vulnerabilities using only good data? What if it isn't about the data but how we send it? This is where web timing and race condition attacks come into play. Let's dive into this crazy world and often hidden attack surface. Awesome. In its simplest form, a web timing attack means we glean information from a web application by reviewing how long it takes to process our request by making tiny changes in what we send or how we send it. And observing the response time, we can access information we are not authorized to have. Race conditions are a subset of web timing attacks that are even more special. With the race condition attack, we are no longer simply looking to gain access to the information but can cause the web application to perform unintended actions on our behalf. Awesome. It's very mature content, as you can see. I think this is created by Tiberius, and by just reading along the uh, the the description, it's look like it's very mature content, right? Somebody with a lot of experience devised this task. Web timing vulnerabilities can be incredibly subtle based on the following research. Okay, we have port swinger research, burp suit research. I think the people who created the burp suit. Let's see what we have here. Listen to the whispers web timing attack that actually work. Okay, so it is created by this James Kettle. It was published on 07 August. Awesome. Okay. All right. Yeah, they have burp suit products and whatnot. All right. Let's continue. Response time differences ranging from 1.3 second or 1300 millisecond to 5 nanosecond. Wow, 5 nanosecond. It's a lot, man. How you can do that? If it is the response time 5 nanosecond is the difference, that mean it is not that much viable. I mean, in today's network, right? So we basically, there is a latency in the ping and the traffic that you send the request and get the response back. But if you need to see that if the 5 nanosecond response is there, that means you must be using the local host to do everything instead of the network, right? Otherwise you will be seeing that the response latency or the difference is in milliseconds. Have been used to stage attacks. Wow. Because of their subtle nature, they can also be hard to detect and often require a wide range of testing techniques. That is true. However, with the increase in adoption of HTTP2, okay, so this is the second version of HTTP protocol. I think they are developing HTTP3 as well. By Google or somebody. I'm not so sure. They have become a bit easier to find and exploit. Okay, the rise of HTTP2. HTTP2 was created as a major update to HTTP, the protocol used for web applications. While most web applications still use HTTP 1.1, there has been a steady increase in the adoption of HTTP2 as it is faster, better for web performance, because you can if you know about the async programming, so basically you can fetch a lot of data on the same connection without depending on other requests to finish first, right? So that's why it is very fast and has several features that elevate the limitation of HTTP 1.1. Yeah, it was slow. And that's why you have a lot of tabs here and it is working just fine, because underneath we are using HTTP2. And even the Chrome itself, if the request is going on 1.1, it will try to upgrade it to the HTTP2 if it is possible. Okay, if it is possible, then it will always go to HTTP2 because it is much faster. Loading and rendering of the page will be much faster because you will receive data very early. However, if implemented incorrectly, some of these new features can be exploited by threat actors using new techniques. Okay, a key difference in the web timing attacks between HTTP 1.1 and HTTP 2 is that HTTP 2 supports a feature called single packet multi-request. Network latency, the amount of time it takes for the request to reach the web server, made it difficult to identify web timing issues. It was hard to know whether the time difference was due to a web timing vulnerability or simply a network latency difference. However, with single packet multi-request, we can stack multiple requests in the same TCP packet, eliminating network latency from the equation, meaning time difference can be attributed to different processing time for the request. This is explained more in the animation below. Okay, so this is what we have, HTTP 1.1. And we are getting back the information on HTTP 2. Time difference in internal latency is 3 milliseconds. Awesome. So this is HTTP 1.1. One request is going, one request is coming back. It was taking 30 milliseconds. And the second one took more. And on HTTP 2, one request came early and the other one came a little bit late. Okay, but we sent it at the same time, so the latency is 3 milliseconds here. With network latency, a thing of the past, only server latency remains, making it significantly easier to detect timing issues and exploit them to recover sensitive information. Typical timing attacks. Timing attacks can often be divided into two main categories: information disclosure and race conditions. Leveraging the difference in response delays, a threat actor can uncover information they should not have access to. For example, timing differences can be used to enumerate the usernames of the application, making it easier to stage a password guessing attack and gain access to accounts. Response delays. I don't know how to use it. Well, let's see. Race condition. Race conditions are similar to business logic flaws in that a threat actor can cause the application to perform unintended actions. However, the issue's root cause is how the web application processes requests, making it possible to cause the race condition. For example, if we send the same coupon request several times simultaneously, it might be possible to apply it more than once. Oh, yeah. So what happens is, for example, if you have 10 servers and you are sending one request multiple times, so the load balancer will send the same request to multiple servers, because usually the algorithm is round robin, so they will try to process it at the same time. And if there is any logic that could create a race condition, then that could happen here. Okay. So usually what happens is people use queues to basically make sure that the one request is being processed at the same time. Okay, I will focus on race conditions. We will take a look at time of check to the time of use, TOC to TOU flow. Let's use an example to explain this as shown in the animation below. Okay, so we have time, we have request 1 and request 2. Code already used, false. Okay. Summary discount code already used, apply the discount code, and then the rest of the things will happen. And since we are sending 2 requests, account is used false for both time, and it will again apply the discount for 2 requests. So that means your commerce site will lose some revenue because the code is used 2 times when it was intended to be used for just 1 time. When the user submits their coupon code in the actual code of the web application, at some point we perform a check that the coupon is valid and has not been used before. So in order to prevent this, I think we need to use some kind of a very high performance memory, where you can check the status of the discount is applied or not, or even if it is being used by one of the transaction which is not completed yet. Even in that case, we need to have some kind of check. So once it is used, then it is permanently blocked. So if it is still in use, after some time you can release the discount code. Okay, so maybe it is stuck somewhere, so user can use it again because it is still there in the card. So this kind of logic you can implement with the very high performance memory. Only then, okay, so in the actual code of the web application, at some point we perform a check that the coupon is valid and has not been used before we apply the discount. The only then do we update the coupon code to indicate that it has already been used. In this example, between our check if the coupon is valid and our update of the coupon being used, there are a couple of milliseconds where we apply the coupon. While this might seem small, if a threat actor can send two requests so close together in time, it might happen that before the coupon is updated in the request 1, it has already been checked in the request 2, meaning that both requests will apply the coupon. Yeah, this is very true. This could happen. Winning the race. Now that you understand basic concept related to the race conditions, let's explore how this vulnerability occurs in a real world scenario. For this, we will take the example of the Ware Valley banking application hosted on HTTP, which is already available here, as we can see. This application allows user to log in and transfer funds between accounts, intercepting the request. Before we start intercepting the request, we need to configure the environment so that as a pen tester, all web traffic from our browser is routed through Burp Suite or suite. This allows us to see and manipulate the request as we browse. We will use Burp Suite, a powerful web vulnerability scanner, to intercept and modify requests. For this exploitation, we can use Burp Suite in the attack box or on the desktop of the attack box. You will see the Burp Suite icon as shown below. Okay, let's run this. And in order to route our request, we need to use the Burp proxy. Okay, we are using the community edition because this is a free edition. There is another one very good tool. It is called Kaido, and it is open source, and a lot of people are using it because it does not limit the attack performance of your pen test like Burp Suite is doing. If you have used the intruder, it will limit the request that we can send. I think 1 request per second in a community edition. If you have professional, then you can do a lot more. All right, let it run. Once the next screen, you will have the option to start Burp. Click on the start Burp button to start the tool. We already did so, right? Yeah, we already did so. There is an update available, but we're gonna go with what we have. User interface. Let's make a little bit bigger. I'm gonna make the font size to be 16. It will make it a little bit, bigger in order to see all the things. Let me see. Okay. Then in the message editor, side panel. Wait a moment. Display. This is the user setting. What about the user interface directly? Sweet. Okay, we are good. Okay, let's go. Here we go. And here is our proxy. It is already enabled. Okay. Once Burp Suite has started, we will see its main interface with different tabs such as proxy, intruder, repeater, etc. Inside Burp Suite, click the setting tab. Okay, on the top right, and you will see the Burp browser option available under the tools. Enable allow Burp browser to run without a sandbox. Why? So here we go. Scanning hostile website without a sender increase the risk of local system being compromised. Okay. We enable it. We take the risk. After allowing browser to run without a sandbox, we would now be able to start the browser with pre-configured Burp Suite proxy. Open the browser by clicking the Open Browser located here. Proxy intercept tab and browse to the particular URL. Okay, they want us to use the inbuilt browser, which is this one, Chromium based browser. I clicked on it, waiting for it to open. Why it is not opening? Okay, I'm clicking on it again. Should not take much time. Yeah. Oh, it opened 2 times, maybe. Yeah. Let me close one time. Let me open the URL. As you can see, I get the request here. I will just forward it. Here we go. And we can see all the requests in the history. Application scanning as a penetration tester. One key step is identifying race condition is to validate functions involving multiple transactions or operations that interact with shared resources, such as transferring funds between accounts, reading and writing to a database, updating balance inconsistencies. For this example, we will log into the Wear Valley banking application using the credentials below. Okay, so if you have a logic in which you need to make sure that there is no race condition and the second transaction, regardless when it was initiated, should not execute on the database before the first one. So in order to do that, you can use the transaction operation that is available in different databases. Even you can start the transaction if you know the Microsoft stack. If you're using C# and with SQL Server, you can start the transaction directly from your code. Or if you don't want to do that, you can also do the transaction in the SQL. So transaction will basically block the tables which are involved in storing the status of the records, and until you complete it or commit it, the second transaction will wait until the first transaction is completed. So this is a very nice way to, it will reduce the overall performance, but it will basically improve the consistency. Okay, so this is how you do. 110 and password is tester. Okay, where is it? Account number is this one. Password is tester. Login. It will block every time, so I'm gonna intercept off. It will automatically forward the request, but the request will still be available in the HTTP history. Okay, so this was the last request. We posted some data, and then it sent us that it needs to be redirected as we received the 302 code, as you can see here, and then we redirected the dashboard. Is there any way to even just a moment, guys, let me increase the interface, side panel, message editor. Okay, let me increase, for example, let's make it 16, so it is a little bit bigger and we can see all the information. Yeah, okay, awesome. Once logged in, you will see the following dashboard that will contain the following two primary functions. So we have 1000 balance, and we can transfer the money by entering the target account number and amount to transfer. Awesome. Okay, you will see two functionalities: logout, which probably does not involve simultaneous toss. The next is fund transfer, which involve deducting the funds from the account and adding them to the other account. As a pen tester, this could be an opportunity for an attack. We will see in detail how, as pen tester, and you can test exploit the vulnerability, verifying the fund transfer functionality. So they are saying, okay, 111 and 500. 111 and 500. Click on transfer. Okay, it is transferred, and we have all the requests here. So this was the post request. We had a session cookie as well. Okay. We'll browse the bank application, perform a sample transaction inside the browser. This will generate multiple get and post requests, and whatever requests we make will be passed through the Burp Suite. As shown in the figure, our current balance is 1000. We will send 500 to another bank account with the account number 111, and while doing that, all our requests will be captured in the Burp Suite. That is very correct. Click on the transfer button and you will see the following message indicating that the amount has been transferred. That is true. So now let's review the fund transfer HTTP post request logged in with the Burp Suite HTTP history option under the proxy tab. So this is what we already saw. So this is post request under transfer. Parameter were provided here, and these are the parameters. Account number is equal to 111 and amount is 500. The above figure shows that the transfer endpoint accepts a post request with parameters, account number, and amount. The Burp Suite tool has a feature known as repeater that allows you to send multiple HTTP requests. We'll use this feature to duplicate our HTTP post request and send it multiple times to exploit the race condition vulnerability. Right click on the post request and click on send to repeater. Okay, send to repeater, control R, and here we go. Okay, now navigate to the repeater tab where you will find the post request that needs to be triggered multiple times. We can change the account number from 111 and amount value from 500 to any other value in the request you can use. Okay, we're gonna go with what they have. Place the mouse cursor inside the request inside the repeater tab in the Burp Suite and press Ctrl R to duplicate the request, and press Ctrl or 10 times to have 10 duplicate requests ready for testing. Okay, now that we have 10 requests ready, we want to send them simultaneously. While one option is to manually click the send button in each tab individually, we aim to send them all in parallel. To do this, click plus icon next to the request number 10 and select create tab group. This will allow us to group all the requests together for easier management and execution in parallel. Okay, so this is second request. I'm pressing just Ctrl or 3, 4, 5, 6, 7, 8, 9, 10. Okay, plus create a group, and I should select all of them. Okay, after clicking the create tab, a dialog box will appear asking you to name the group and select the request to include. For example, we will name the group funds and select all the requests and then click the create button as shown below. Okay, let's go with funds. Create. All right, so we have funds here, and we should have group option in sequence. In yeah, we want to go with the send group in parallel, last byte sync. All right. Now we are ready to launch multiple copies of our HTTP post request simultaneously to exploit the race condition vulnerability. Select send group in parallel, last byte sync in the drop down next to the send button. Once selected, the send button will change to send group parallel. Click this button to send all the duplicate requests in our tab group at the same time. Okay, let's do that. Alright, send group parallel, and here we go. We sent all of them. Okay. Once all the requests have been sent, navigate to the tester account in the browser and check the current balance. You will notice that the tester's balance is negative because we successfully transferred more funds than were available in the account. Exploit the race condition vulnerability. Wow. Okay, let's see. Oh yeah. By duplicating 10 requests and sending them in parallel, we are instructing the system to make 10 simultaneous requests, each detecting 500 from the tester account and sending it to the account 111. In a correctly implemented system, the application should have processed the first request, log the database, proceed the remaining requests individually. However, due to the race condition, the application handles these requests abruptly, resulting in a negative balance in the tester account and an inflated balance in account 111. Verifying through source code. Suppose you are a pen tester with access to the application source code, as in a white box testing scenario. In that case, you can identify potential race conditions, a vulnerability through a code review. By analyzing the code, you can pinpoint areas where multiple database operations are performed without proper transaction handling. Transaction handling is the important word here. Below is the Python code that handles the fund. So if you are using, for example, Entity Framework, it will automatically add the transaction to the query. Okay, or you can explicitly mention that I need to go with the transaction because I'm updating the database. And here we are just executing the raw query, which is also a bad practice. Because you should go with the SQL queries or SQL side store procedure or something like that. I'm not sure it is a parameterized query or not because I'm not familiar with much with the Python, but I think this will be okay here because we are passing the values through a parameter instead of hard coding here. But still we are making it like plus and then rest of the thing. So it could be, there could be a SQL injection issue available here. Okay, but we are doing con.commit in order to commit the funds. In the above code, if user balance is greater than count the amount, the application first updates the recipient's balance with the command update user set balance is equal to balance plus where the account number is, followed by a commit. Then it updates the sender balance using update. So all of these should be in one transaction. Either you succeed both together or they roll back together. It updates the sender balance using update user set balance is equal to balance minus somewhere account number is equal to question mark and commits again. So that means it is committing and that means it is using the transaction, I think, but there should be just one commit once both of the queries are executed. Since these updates are committed separately, not part of the single atomic transaction, this is very important. There's no locking or proper synchronization between these operations. This lack of transaction or locking mechanism makes the code vulnerable to race conditions, as concurrent requests could interface with the balance updates. Time for some action. Now that you understand the vulnerability, you can assist glitch in validating it using the account number 101 and password is glitch. Attempt to exploit the vulnerability by transferring our 2000 from his account to the account number 111. Okay. So now we understand this, we can assist glitch in validating it using the account number 101 and password is glitch. Attempt to exploit the vulnerability by transferring our 2000 from his account to the account number 101. Fixing the race condition. Just a moment. So here is what we have. This is the account number. The developer did not properly handle concurrent requests in the bank application, leading to a race condition vulnerability during fund transfers. When multiple requests were sent in parallel, each deducting and transferring funds, the application processed them simultaneously without ensuring proper synchronization. This resulted in inconsistent account balances, such as negative balance in the sender's account and excess funds in the recipient's account. Here are some of the preventive measures to fix the race. Use atomic transactions. The developer should have implemented atomic database transactions to ensure that all steps of a fund transfer, deducting and crediting balances, are performed as a single unit. This would ensure that either all steps of the transaction succeed or none do. Preventing partial updates that could lead to an inconsistent state. Implement mutex logs. By using mutex logs, the developer could have ensured that only one thread accesses the shared resource, such as account balance at a time. This would prevent multiple requests from interfering with each other during concurrent transaction. Apply rate limit. A developer should have implemented rate limiting on critical functions like fund transfers and withdrawals. This would limit the number of requests proceed within a specific time frame, reducing the risk of abuse through rapid repeated requests. This is very true. All of them are very valid. After completing the exercise, you will be requiring to visit dashboard to get the flag. Okay. What is the flag value after transferring our 2000 from glitch's account? Okay, now that you understand the vulnerability, we can assist glitch in validating it using the account number 101 and password is glitch. Okay. So phone number is 101 glitch. Okay. Attempt to exploit the vulnerability by transferring our 2000 from his account to account number 111. Okay. So first of all, before we do that, we need to capture this request. So in that case, let me intercept it here. Okay. Target count is 111. We need to transfer 2000 and click on transfer. And come on, we have the request here. Let me send it to the repeater. Here we have all the requests in the repeater. I'm gonna close all of them. Alright, so control all 20 time, and let's create a group here. Let's all add all of them. After fix funds, create, and we want it to be sent parallel and send in a group. Let's see what happens here. Okay. So once I did that, let's see the dashboard. So this is blocked here. Intercept is off, and here we go. Wow, minus 18,000. Okay, so this is our flag. I'm gonna put it here, and we are good to go. If you enjoyed this room task, feel free to check the race condition room. There is a specific race condition as well, where balance is shift and number sort. Look for entry and open door. Wow, awesome. Thank you guys for joining me on this journey. We have completed our task 18. In the next video, we're gonna start the task 19. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build the community. And if you have any comments, please mention in the comment section down below, and I will see you in the next video.